Welcome back to The Explainer. Today we're diving into something completely invisible to the naked eye, yet it entirely dictates the survival of massive multi-million-dollar facilities. I'm talking about water. Now, you already know water is the critical lifeblood of any heavy-duty cooling infrastructure, right? It absorbs and moves heat better than almost anything else. But here's the catch. Left completely to its own devices, water is actually highly destructive. Today we're looking at exactly what a chemical dosing system is and why it is absolutely necessary for both chilled water and cooling water lines to keep our giant machines alive. Let's get into it.
Here's our roadmap for today. We'll start with the hidden threats lurking in the water, map out the open versus closed loops, identify forward deadly dangers, break down the dosing system's anatomy, examine its chemical arsenal, and finally wrap up with the ultimate return on investment.
Section 1. The hidden water threat. The enemy within.
So there's this massive central conflict in facility management. You absolutely need water to run your cooling networks, but consider this fundamental truth. Without treatment, the very water meant to cool the system will literally destroy it from the inside out. You can buy the most expensive chiller in the entire world, but if the water running through its pipes is untreated, that machine is going to fail, period. The chemical dosing system acts as an automated immune system for your facility, constantly fighting off relentless internal diseases.
Section 2. Open versus closed loops, the two battlegrounds.
Before we look at the cure, we've got to understand the battlegrounds, right? We're dealing with two main types of lines. On one hand, we have the open loop, which is your cooling water line. This water travels out to the cooling towers, it's exposed to the atmosphere, meaning it relies on evaporation to release heat. Because of that, the water levels constantly drop, leaving behind highly concentrated minerals. Plus, it acts like a giant air scrubber, pulling in airborne dust and microbes. It's just a chaotic, highly vulnerable environment. Then, on the other hand, we have the closed loop, or the chilled water line. This water circulates internally to cool the actual rooms or servers. It's completely sealed from the atmosphere, so there's no evaporation. But don't let that fool you. It is highly prone to dissolved oxygen attacking the metal pipes and causing severe long-term corrosion. Two very different loops with two very different sets of vulnerabilities.
Section 3. 4 deadly water dangers, the 4 horsemen. Okay, so what exactly are we fighting in these water lines? If left unchecked, these 4 horsemen of cooling failure will absolutely bring your system to its knees. First up is scale formation. This is calcium and magnesium literally hardening on your pipes. Second is corrosion, where dissolved oxygen and chlorides eat away at the metal. Third is biofouling, which is just a fancy way of saying the growth of gross slime, algae, and dangerous bacteria. And fourth is concentration, where evaporation in the cooling tower causes those excessive, damaging mineral spikes. Now, check out this massive single number, 1 millimeter. You might be thinking, hey, a tiny bit of scale isn't a big deal, right? Wrong. Calcium carbonate scale acts as a massive thermal insulator. If just 1 millimeter of scale builds up inside the copper tubes of a chiller's condenser, the heat transfer efficiency drops so drastically that the chiller's power consumption spikes by 10 to 15%. Just try to imagine your facility's massive energy bill jumping 15%, all because of a microscopic layer of crust. No way you want that.
And honestly, it gets worse. We are just dealing with a loss of efficiency here. Corrosion doesn't always happen evenly. It often results in what we call pitting, where it basically drills tiny, super deep holes straight through the metal, causing massive and totally unexpected water leaks. On top of that, your cooling tower water usually sits right around 30 to 37 degrees Celsius. That happens to be the exact perfect incubation temperature for dangerous biological threats, including Legionella bacteria, which poses a severe, legally regulated health risks to people.
Section 4. Anatomy of the dosing system. The automated doctor.
So what is a chemical dosing system? And how does it actually stop these threats? Well, think of it as an automated doctor. It isn't just a dumb pump. It's a highly intelligent, closed-loop feedback system. Step 1 is sense. The system has a manifold of super-sensitive probes constantly measuring the water's electrical conductivity, pH balance, and ORP, which stands for oxidation reduction potential. Step 2 is calculate. A main controller acts as the brain, analyzing all this real-time data against really strict set points. And step 3 is dose. If the water is even slightly out of balance, the controller commands precision diaphragm pumps to inject the exact required cure, quite literally down to the milliliter per hour. It's perfectly calculated medicine.
But hey, chemicals aren't the only answer here. We also have the motorized blowdown valve.
Remember how we talked about mineral concentration from evaporation? Well, when the system's conductivity sensors detect that the water has become way too thick with dissolved minerals, the controller automatically opens this motorized valve. It bleeds off the dirty, highly concentrated water right down the drain, which makes room for fresh, clean, makeup water to enter the system. It's basically like automated kidney dialysis for your cooling loop.
Section 5. The chemical arsenal, the medicine.
So what exactly are these pumps injecting into the water lines? Let's open up the arsenal. First, we have scale and corrosion inhibitors. These are actually pretty fascinating. They form a microscopic molecular protective film right over the metal pipes, which blocks oxygen from touching the metal and prevents calcium from crystallizing. Next up, oxidizing biocides, like chlorine and bromine. These act like brute force, chemically burning and destroying the cell walls of algae and bacteria. Then we have non-oxidizing biocides, which are a bit more insidious. They actually poison the microorganisms and paralyze their metabolism. And finally, pH adjusters. These ensure the water stays right in that sweet spot of 7.5 to 8.5, because water that's too acidic will eat the pipes, and water that's too alkaline will cause massive scale.
Now, check out this brilliant tactical move. You might be wondering, why do we need two different types of biocides? Well, because bacteria are surprisingly smart. If you just hit them with chlorine every single day, they're eventually going to build up an immunity to it. So, by alternating the treatments, cross-injecting oxidizing cell wall destroyers one day and non-oxidizing metabolism paralyzers the next, the bacteria literally never get a chance to adapt. It is microscopic chemical warfare at its absolute finest.
Section 6. The ultimate return on investment, macro impact. Let's zoom out for a second. We've talked a lot about microscopic slime and chemistry, but why is this system so necessary? Why do facility managers care so deeply about this? Well, here is your ultimate return on investment. First, by preventing that 1 millimeter of scale, you guarantee your chiller runs at 100% of its peak energy efficiency, or COP. That translates to massive energy savings. Second, by stopping corrosion, you drastically extend the life cycle of your highly expensive copper tubes and field piping. Third, through automated blowdown, you aren't just blindly dumping water. You actively conserve water by only flushing it exactly when it's necessary. And finally, you ensure strict legal compliance against deadly diseases like Legionella, all while keeping your human workers perfectly safe from having to manually handle toxic chemicals.
So I want to leave you with this final thought. In a world completely fixated on massive hardware, we're talking giant chillers, hyperscale servers, huge cooling towers, are you neglecting the microscopic chemistry that actually keeps it all alive? Hardware is really just metal. It's the precisely dosed chemistry in the water that gives that metal a long, efficient life. Thanks so much for joining me on this deep dive into chemical dosing systems. Keep asking questions, keep looking at the details, and I'll catch you on the next explainer.